Hello and welcome to CE 108 Hydraulics. Today I will introduce you to fluid mechanics. Let me read to you the outline of topics for our first lesson. So number 1 is the definition of hydraulics. Number 2, the definition of fluids and types of fluids. And number 3, the properties of fluids. So at the end of this topic, the students should be able to A. Define hydraulics and fluid mechanics, define and explain properties of fluids, and solve problems regarding fluid properties. So, fluid mechanics and hydraulics represent that branch of applied mechanics that deals with the behavior of fluids at rest and in motion. In the development of the principles of fluid mechanics, some fluid properties play principal roles, others only minor roles or no roles at all. In fluid statics, specific weight or unit weight is the most important property, whereas in fluid flow, density and viscosity are the predominant properties. Where appreciable compressibility occurs, principles of thermodynamics must be considered. Vapor pressure becomes important when negative pressure gauge are involved, and surface tension affects static and flow conditions in small passages. So again, in fluid statics, since hindi gumagalaw ang fluid, specific weight yung pinaka-importante niyang property. Pero once na ito ay gumagalaw, dito papasok yung concept ng density and viscosity. So later we will define everything about these properties. So for the properties of fluids, that is, this presentation was made by Engineer Precious. So thanks to her, I will use this as a template for the discussion. Fluid mechanics is defined as the science which deals with the action of fluid at rest or in motion, whereas the hydraulics is a branch of science concerned with the practical applications of fluids, primarily liquids in motion. It is a science embodying the laws that relate to the behavior of liquids, particularly of water or oil. So, hydraulics can be subdivided into the following branches. We have here hydrostatics, which deals with liquid at rest, hydrokinetics, which deals with the laws governing the flows of liquids, and hydrodynamics. It deals with the forces exerted by the liquids in motion to the other object. So, what is fluid? Fluid generally is any material that cannot sustain a tangential or shearing force when at rest and that undergoes a continuous change in shape when subjected to such a stress. Fluids comprise a subset of the state of matter and include liquids and gases. So fluid, again, can be divided into two. It can be either a liquid or a gas. liquid are fluids that are incompressible, while gas are fluids that are compressible. So for the next slide, I will insert here a clip about the explanation of compressible and incompressible fluids.
Alright, welcome back. So in the previous video, we learned about liquids and how liquids are incompressible fluids, or more technically, they are nearly incompressible. But just for the sake of this discussion, we're gonna make the assumption that all liquids are pretty much incompressible. So what does that actually mean? Well, if you had a container that had some water in it, right? So all these water molecules you poured into the container, and after some while, these water molecules would eventually settle down into a calm or steady state, right? So the reason we call fluids, or more specifically liquids, incompressible fluids is because each of these water molecules are closely packed to one another. In other words, there's hardly any space left between each of these molecules. So if you were to come into this container and try to squeeze the water molecules even closer together, you could not do so. And that is because water molecules have bonds that are strong enough to keep the molecules packed very closely with one another, or in other words, they are attracted towards one another, but the bonds are weak enough to where, if you placed your hand inside this container and moved your hand around, the water molecules would slide past one another, they would slide past your hand and move around. But as soon as you removed your hand from this container, eventually the water molecules would just settle down into some type of a steady state, as it is here. So in other words, liquids are incompressible fluids. And more specifically, liquids, when they are settled down into a container like this, they will eventually form a well-defined surface, right? They are going to take the shape of their container, but then after a while, you could clearly define a well-defined surface for water. So I think we're pretty comfortable with the idea of incompressible fluids. And in the previous video, I did pose the question, well, if there are incompressible fluids, there surely must be some type of compressible fluid, right? So let's try to understand what a compressible fluid is, right? If the main characteristic of a incompressible fluid or a liquid is that the molecules are packed closely to one another, well, intuitively we could think of compressible fluids as molecules that have a lot of space between one another. And compressible just means that the space between the molecules can be shrunken. In other words, for a compressible fluid, we could actually squeeze the container and the space between each molecule will get smaller and smaller. So these types of fluids, compressible fluids, are often known as gases, right? And we're familiar with gases, right? If we pump air into a basketball, that is a compressible fluid. If we pump helium into a balloon, that is a compressible fluid. Now, these molecules, so let's say we're pumping up a basketball with some air. If we inject the air into an empty basketball, you're going to have air molecules, often, nitrogen, oxygen, all that stuff that we breathe in air. They're going to be floating around freely inside of that container or basketball. And they're going to be moving around any which way very randomly, and every once in a while, these molecules will collide with one another, or they will collide with the walls of their container. So as you compress the container where gases are living, you're going to decrease the space between each molecule. And consequently, you'll actually increase the number of collision, right? The smaller the space is between each one of these particles, the more often the molecules will collide with one another and the inside surface of their container. Now, the main difference between liquids and gases is the gas molecules here will take up space freely inside of the container, whereas liquids will eventually settle, and that is why this well-defined surface line is so important for understanding liquids. But the biggest idea here is that both liquids and gases are simply types of fluids, where liquids are incompressible fluids and gases are compressible fluids. So we've been talking a lot about liquid molecules and gas molecules and solid molecules, and I want to take a step further into that discussion, into that topic, and really try to conclude what exactly the study of fluids is, and we'll do that in the next video.
Now, what are the types of fluid? Fluids are divided into two types, the ideal and real fluids. And under real fluids, we have Newtonian fluids and non-Newtonian fluids. And also under non-Newtonian fluids, we have three: the pseudoplastic fluids, the latent fluids, and Bingham fluids. So later on, we will discuss each and every types of fluids that we have here in the illustration. So next, we have the types of fluid. Fluids are generally divided into two categories, which is the ideal fluid and real fluids. Ideal fluids has no viscosity, it is incompressible, it has a uniform velocity, it has no friction between layers, and no eddy current or turbulence. So the biggest example I have here is water. Water is an ideal fluid because number one reason, incompressible ang tubig. It has also uniform velocity. It is not viscous, or sa Tagalog, yung lapot niya, it is not very viscous na. It has no friction between layers. So, kung ikis-kis mo, wala ka ring mararamdamang anything na friction against it. And, on the other hand, real fluids exhibit infinite viscosity. It has non-uniform velocity when flowing. It is compressible, and it experiences turbulence. So, example for real fluids naman are oil. Diba? Kasi, it can be subjected to pressure kasi nakakompress. Also, it has infinite viscosity and the velocity can also be non-uniform. So, there. Real fluids are further divided into one, Newtonian fluid, which is a fluid in which the viscous stresses arising from its flow at very point are linearly correlated to the local strain rate or the rate of change of its deformation over time. Newtonian fluids are the simplest mathematical models of fluids that account for viscosity. While no real fluid fits the definition perfectly, many common liquid and gases such as water and air can be assumed to be Newtonian for practical calculations under ordinary conditions. On the other hand, non-Newtonian fluid is a fluid that does not follow Newton's law of viscosity, that is, constant viscosity independent of stress. In non-Newtonian fluids, viscosity can change when under force to either more liquid or more solid. So the key word here for Newtonian fluid is the viscous stresses are linearly correlated to the local strain rate. While in non-Newtonian fluid, you just have to remember that viscosity can change when under force to either more liquid or more solid. An example for Newtonian fluid is ito stated here, water and air. It can also be alcohol or yung mga hindi masyadong viscous na liquids. While in non-Newtonian fluid, it can change kasi when subjected to force. So, the best example for this are toothpaste, cosmetic products like lotions, and etc. And also butter. Since kapag subjected siya into an extreme, nagbabago-bago siya.